Hello everyone, welcome back to Algebra 2 class. I hope you all had a great weekend. Today we are going to continue to discuss something about the exponential function. And this time we are going to work on how to solve exponential equation. So exponential function, as we mentioned, the most important feature of exponential function is um, for exponential function, the variables is exponents, right? So as we mentioned before, and also we discussed based on the real life situation, we can talk about exponential growth, exponential decay. But the reason we call exponential function because the variables is exponents. You can have all different format. Sometimes you might see this kind of format, but they actually talk to the very similar different situation, similar situation because exponents is variable. For exponential equation, so you probably guessed, once I, for example, once I have a number, then this type of an equation called exponential equation. And you can see variables are exponents. So that's quite, different compared to the regular equation we solved before. We solved a quadratic equation. We can use zero product property to lead us to solve this. And today we are going to discuss what kind of methods can we use to solve exponential equation. Let's check first several examples here. As you can see, all equations, the most important feature here are variables are exponents. So that's something we didn't see before. And the method we use here is called the common base. So when you see the word common base, probably you are a little bit confused. But one thing, remember, the number here is called base. For example, 3 to the second power, 3 is a base. Exponent is 2. Same thing here. So common base is, the idea is, if I have a same base, then they should have same exponent. So for example, I'm just going to write it down as a side note later. I'm going to erase it. Let's say 3 to the second power, and this is 3 to the x power. Since they have the same base, so in order to be equivalent value, x must be 2. So this is the idea, same base, same exponents. So we are going to use this idea to help us to solve equation. So that's why we call this method as common base. Okay, now let's check. I have the base as 2, 2 to the x power. Since I want to change it to the same base, so I'm going to see what's a connection between 16 and 2. As we all know, 16, I'm going to use a different color. 16 is 2 to the fourth power. 2 times 2 times 2 times 2 is 16. So now, as you can see, we have a same base, so x must be 4. That's it. So it seems pretty easy, right? So the idea is we are going to use common base. Let's check the second one to, readdress this, the importance of the common base. And you can definitely, practice this process or even just pause the video, solve this on your own, so you can be more familiar with this process. Again, 27, I'm going to observe what's the connection between 27 and 3. So as we know, 3 times 3 is 9, then times 3 again is 27, so 3 times. Then clear x equal to 3, right? So last one. And sometimes remember, the situation is not always so ideal, so easy. We just need to deal with like integer exponents. So far, we've learned, rational exponents with no negative exponents. So we have to be careful what kind of base we have to work on. Last one here, So 1 over 25. So the first time you see is, I know, so probably you remember 25 is 5 to the second power, right? So 25 is 5 to the second power. But this is 1 over 25, so do not forget the negative exponents always defined as 1 over something. So this whole thing is actually 5 to the negative 2 power. So whenever you see 1 over something, you can just try to link to the negative exponent. So 1 over something can, probably it's not a good idea using x since our x is exponent. So let's see, 1 over some number. This one, you can think about the negative exponents. So since we figure out this is negative 2, then x, same base, again, same exponent. So this is how do we find the answer for this kind of thing. Again, the situation is we sometimes it's easy to see the connection between the two base. 27 does related to 3, 16 related to 2, 25 related to 5. But sometimes what if the two sides not so easy to see? Let's check this example here. Okay, so this one is actually not so bad. So again, I strongly suggest you pause the video, try these two equations on your own, and let's see what we can do. Again, we need to focus on the common base. Common base is we need to change to the same base. So when we observe it, clearly we know 27 is 3 to the third power, as we just did. So now we know the exponents is the same. So remember, exponents part are the same, which means x plus 1 equal to 3. So now we just need to solve like a regular equation, right? That's it. So sometimes even more steps, even we're dealing with a little bit complicated exponents. But remember, as we have a same base, exponents must be same. Okay, now this one can be a little bit tricky. We know 16 is related to 4. So sometimes you say, how do I change it? So idea is, it's not always changing the number part. Sometimes you might want to change something, to the variables part, so you can lead to the same base. So this idea is, I know 16 is 4 to the second power because 4 times 4 is 16. So I'm going to change the 16 to the 4 to the second. Remember, the left side is 16 to the x power. I just replace 16 as 4 to the square, then 4. So now is 4 2x. Remember, x to the exponent's power is 1. So this one, so some students might say, oh, that doesn't mean 2x equal to 0. It's not. It's 2x2 invisible 1 here. So 2x equal to 1. Then x is, we divide by 2 here, 1 over 2. Okay? Now, last part. So this one is going to be a little bit challenging one for us to understand. As I mentioned, situation is sometimes it's not so easy to always see the connection between the two bases here. So what we do here is I'm going to try to set a bridge between these two bases. So I know there's no way I can change 8 to some power to 32. It's just not directly related, right? So since they are both even number, I'm going to do some bridge here. What is a bridge I'm looking for is I'm going to find a number. I can change both sides to that number. So which number will you try? My way to understand this is since they're both even number, I'm going to try 2. Let's see, I know 8 is 2 to the third power because 2 times 2 times 2 is 8. And I know, let's try the different color. 32 is 2 to the, some students might a little bit confused about this part, but try to just do some mental math. You will figure out 2 to the fifth power is 32. See? Now I have same base. See, that's a bridge I'm talking about. This is how I connect these two numbers. So I'm going to change the both sides. So 8, I'm going to replace to the 2 third power x. 32, I'm going to change 2 to the fifth. Now, do we have the same base? Yes, we do. So 2 to the 3x, 2 to the 5, then 3x equal to 5, right? Same base, same exponent. So I just solve equation like a regular one. Then x is 5 over 3. We are finished. So as you can see, sometimes changing base idea is not so directly to be seen. Sometimes you have to think about a number to change both sides to be same. And sometimes we can just easily to change them like this one. Sometimes we change with variable size. Sometimes we change, the number part. But the key idea is always common base. Okay, that's how do we use common base to solve exponential equation. And soon we are going to discover a new method to solve exponential equation. That's like more universal way. So thank you so much everyone for watching this video and study this topic with me. I hope this video is helpful. See you soon everyone. Take care.